Alright guys, we're also going to work on a second practice problem, and this is number 4. And this problem is going to be the exact opposite of what we did in number 1. So you're still going to look for your given and your need. And so if we read the problem, how many grams of hydrogen are necessary to react with 21.85 moles of carbon monoxide? So we're going to start by finding our given and our need. Our given is the number, so it's 21.85 moles of carbon monoxide. Remember, they're both capital letters, so they're two separate elements. And then our need is how many grams of hydrogen. So we're looking for grams of H2. So we're going to draw our train tracks. And we always put our given in the top left. So 21.85 moles of carbon monoxide. First, we need to convert from moles of carbon monoxide to moles of hydrogen. And we're going to use our balanced chemical equation for this. If we look in front of CO, there's no number, so we assume there's a 1 there. If we look in front of H2, there is a 2. We then have canceled out moles of carbon monoxide and are left with moles of hydrogen. We then need to convert from moles of hydrogen to grams of hydrogen. And we do that using our molar mass. The molar mass of H2 is 2.02 per 1 mole. If you don't know how I got that number, please reference the instructional videos posted on Tuesday. So you multiply across and divide down, so we get 21.85 times 2 times 2.02 divided by 1 times 1. You multiply across and divide down, and you plug that into a calculator, and you get 88.27 grams of H2. So now let's go over the basic structure that we're going to use to plug into these problems. As always, you're going to plug your given in your top left. In this case, my given was moles. You're then going to use moles of given to convert to moles of need. And in order to do this, you're going to use your balanced equation. And if you look, you're going to look at the coefficients in front of each compound. We then need to cancel out. So we'll have 1 mole of need, per grams of need. And we're going to use this because we're going to plug in our molar mass of need right there. This is always going to be a 1 because the units of our molar mass are grams per 1 mole. If you plug in these numbers, you multiply across, and you divide down, you're going to be able to solve every single one of the problems by plugging things into this structure. If you have any questions, guys, please reach out to me via Remind. I'm here to help.